Hi, welcome on the description on volumetric analysis. Our part will consist on 4 points or parts. First part, we will deal on the introductory part of volumetric analysis. The second part will be on the aims and requirements. Third part will be on the procedures, and the last part will be on the calculations. By starting on the introductory part on volumetric analysis, by definition, volumetric analysis is the determination of amount of substance present in its solution to react quantitatively with another solution of known concentration, and a technique where a solution of known concentration is used to determine the concentration of a known concentration is known as titration. On this part, there are terminologies you must know. The first terminology is standard solution. A standard solution is the solution with a known concentration. And the second is concentration. Concentration is the amount of salt in a gram dissolved in 1 liter. Its SI unit is gram per dm cubic. Another is molarity. Molarity is the amount of concentration of solute dissolved in 1 liter. Its SI unit is molarity per decimeter cubic. Another is neutralization. Neutralization is the reaction between acid and base to produce salt and water. At neutralization point means there is no excess hydrogen ions and hydroxyl ions within a solution. Another is equivalence. Equivalence point is the point whereby the number of moles of acid is equal to the number of moles of base. Another is endpoint. Endpoint is determined by an indicator where a solution changes color. Another is an indicator. An indicator is a chemical detector of a solution to detect the endpoint of a solution. Our question is to estimate the amount of hydrochloric acid present in 500 ml of a given solution using 0.1 molarity of sodium hydroxide solution. Let us continue with another part.
Aim. The aim of experiment is to estimate the amount of hydrochloric acid present in 500 ml of a given solution by using 0.1 mole of sodium hydroxide solution. Apparatus required. Apparatus required on this titration are beaker. This is an apparatus that is used to keep a solution. Another apparatus is burette. This is an apparatus that is used to hold titrant. Another apparatus is conical flask. This is an apparatus that is used to hold analyte. Another apparatus is glass tiles. Glass tiles, this is an apparatus that is used to show color clearly at the end point of titration. Another apparatus is pipette. This is an apparatus that is used to pipette the volume of a given solution. Another apparatus is brush. This is an apparatus that is used to clear another apparatus. Another apparatus is dropper. This is an apparatus that is used to hold an indicator. The last apparatus is retort stain. This is an apparatus that is used to hold burette. Chemicals required. Chemical required on this titration are sodium hydroxide solution. Another chemical is hydrochloric acid. Another chemical is distilled water. And the last one is methyl orange as an indicator. Let's continue with another part of procedure.
Welcome to another part, which is the procedure part. In titration, the following procedure must be considered. First, you take the bullet, rinse it with the distilled water. Rinse it again with acidic solution, which is the hydrochloric acid, in order to remove the impurity which can affect concentration. Rinse it horizontal, then remove the acidic solution. Take the bullet and hold it to about the angle of 45 degrees. Then pour acid into the bullet. Adjust up to the level of 0 degree, whereby the lower meniscus of the bullet should touch at 0 reading. Then mark the initial reading from the bullet. Fix the bullet at the retort stand to about 90 degrees. Another procedure is followed by collecting the basic solution, which is sodium hydroxide, by the help of pipette. First, rinse the pipette with distilled water. Rinse the bullet with the basic solution. Then remove basic solution from the pipette. Pipette basic solution to about 20 mark from the beaker. Fill the basic solution to the clean conical flask. Whereby the tip of the pipette should touch at the wall of the conical flask. Then add 2 drops of methyl orange indicator. The color changed from colorless to yellow. Then start to titrate. First, place the conical flask under the bullet, whereby the nozzle or the bullet should be exactly at the middle of the conical flask. Start to titrate slowly. The last dot causes the color change from yellow to pink. Then mark the final reading from the bullet. The final reading is 20.1. Repeat the same procedure to obtain more result. Our third titration, the final reading is 19.8. Then record the data into a tabular form, whereby the table will be shown as follows.
The last part of our experiment is calculation. From there, 20 centimeter cube of sodium hydroxide reacted with 20 centimeter cube of hydrochloric acid. From the equation, sodium hydroxide reacted with hydrochloric acid to form salt and water. From the equation, we have given the molarity of sodium hydroxide. Then, we are required to find the molarity of hydrochloric acid. From the formula, molarity of acid times volume of acid divided by number of moles of acid is equal to the molarity of base times volume of base divided by number of base. From there, we are making the subject molarity of acid. Acid equals to molarity of base times volume of base times number of moles of acid divided by volume of acid times number of moles of base, where molarity of acid equals to 0.1 molarity of base times 20 centimeter cube volume of base times 1, which is the number of acid, divided by 20 centimeter cube volume of acid times 1 number of mole of base, in which the molarity of acid is 0.1 mole per dm cube. From there, we are finding the concentration of hydrochloric acid in gram per dm cube. Molarity equals to concentration in gram per dm cube divided by molar mass, which is in gram per mole. Then concentration in gram per dm cube equals to molarity times molar mass. Then concentration in gram per dm cube equals to 0.1 molarity of hydrochloric acid times 36 0.5 gram per mole molar mass of hydrochloric acid. Then the concentration in gram per dm cube of hydrochloric acid is 3.65 gram per dm cube. Then the last part of our experiment is to find the concentration of sodium hydroxide in gram per dm cube. From the formula, molarity equals to concentration over molar mass, where concentration in gram per dm cube equals to molarity of sodium hydroxide times molar mass of sodium hydroxide. Then concentration of sodium hydroxide in gram per dm cube equals to 0.1 times 40 gram per mole, where the concentration of sodium hydroxide in gram per dm cube equals to 4. Thank you.
I'm Deogracius Francis Chilambo. I'm a member of group number 5, and I'm here to thank Madam Mosh, a project supervisor, Mr. Robert S., lab supervisor, for their great support for the successful of this project. And also I take this time to thank all members of the group for their great support and accomplishment of this project.